Hi guys, welcome to 16.2. We are going to do one review of Polar. We're going to skip Battleship today. And then we are going to do polar coordinates and rectangular conversion. We've done rectangular conversion for points. Today we're going to do rectangular conversion for equations. Fun stuff. Skip Battleship. There we go. Okay, so this is a slide you should know. We know that x squared plus y squared equals r squared. When we do our conversion from rectangular equations to polar equations, we're going to want to keep this kind of in the back of our minds, and that r is equal to the square root of x squared plus y squared. Okay, that's one set of conversions that you're going to want to know. Okay, the next is that the tangent of theta is y over x, and we did this one in our last lesson, so that means theta must be inverse tan of y over x. Okay, the new ones that we're going to do today we're going to try to convert x's into r's and y's into r's. Well, how are we going to do that? So we have, I'm going to write an equation that has to do with x's and r's. So let's write it in terms of cosine. Cosine of theta is equal to adjacent over hypotenuse, x over r. So there's an equation that has x's and r's. So if I wanted to write this just in terms of x, you could say x is equal to r cosine theta. Same with the y. So y would be sine. Sine of theta is equal to opposite over hypotenuse. So if I wanted to write this equation in terms of y, r sine theta. Okay, so I've got kind of three sets of equations that I want to keep in my back pocket when I'm trying to write equations in terms of just r or just theta. Okay, let's do one quick review question. Let's do number 2. So I see, if we had to graph this, a polar coordinate that extends left 3 and rotates pi over 4. So that would land somewhere about there, okay? And now we want to change this to rectangular. Well, what I know from my terrible triangle is that this distance is 3, and I need to figure out my side lengths. Well, this is a special right. They are all going to be special rights. This is a 45, 45, 90 triangle, which means that this side is 3 over root 2, and this side is 3 over root 2. Now we're in quadrant 3, so we're going to want to make sure that it's negative 3 over root 2 and negative 3 over root 2. Here is polar. Here is rectangular. Okay. Today, we are going to change these guys. Take a look. We've got equations in terms of x and y, and we're going to change them into polar. And at the bottom, we're going to change polar to rectangular. Okay, so I see that in purple it says do A last, which means it's probably not good. So let's go straight to B. Okay, so we've got, and notice we've got a little key up here, that we've got x equals r cosine theta, y equals r sine theta. We've got x squared plus y squared equals r squared, which means r equals the square root of x squared plus y squared, plus minus. And we've got tangent theta equals r plus or y over x. Okay, so let's go to B. So I'm going to do that swap. I'm going to say that y is equal to r sine theta, and that x is equal to r cosine theta. I need the negative r cosine theta. Okay, what do we do with this? Well, we want to get, sometimes we want to get theta by itself, and sometimes we want to get r by itself. And I think once you start doing this a little bit, you can see, let's see, if I divide, you're going to kind of get a feel for which one you need to do. I'm going to divide both of these by r cosine theta. Why did I do that? Well, I'm going to get a 1 on the left side, -1 on the right side. And then I've got sine over cosine. Well, those r's are going to cancel, and I'm left with tangent theta equals -1. Okay, and we're always solving. We're going to solve for r or theta. Okay, so if I solve for theta, I get inverse tan of -1. Okay, how is this the same equation as y equals -x? Well, if I were to graph y equals -x, it's a line. It looks like that. Okay, so if I had to graph theta equals inverse tan of -1, well, where is tangent equal to -1? Tangent's equal to -1 in quadrant 2 and in quadrant 4. And the r doesn't matter. If I had to solve this, I'm not going to solve, we've got two different thetas. Theta could be, what would it be, 3 pi over 4, and theta would be 5 pi over 4 to get -1. Okay, so if theta was 3 pi over 4 and the radius was 2, we would land here. If it was 5 pi over 4 and the radius was -2, it would land there. If the radius was 1 and 5 pi over 4, it would land here. So the radius doesn't matter. This equation, theta equals inverse tan of -1, would produce that line in a polar graph. Okay, let's try another one. So let's do C. Y equals x squared. So we've got r sine theta equals r cosine theta squared. Let's distribute the square. Okay, again, you're gonna, I see that if I divide by r cosine squared theta, on the right hand side, the cosine squared thetas cancel, I'm left with r. And on the left hand side, the r's cancel, and you're left with sine theta over cosine squared theta. Now, I need you to reach your brains all the way back to Unit 13. We've done, this is a trig identity. Sine over cosine theta is tangent theta, which leaves 1 cosine on the bottom. So 1 over cosine theta is secant theta. It's a trig identity. So the first one was in terms of theta, and now this one's in terms of r. What the heck? So I'm going to have you grab your graphing calculator, pause and grab your graphing calculator, and we're going to type this into our graphing calculator. So the first thing that you have to do, we haven't done this mode before, is hit your mode button and then change your mode to polar mode. So if you look in your modes, it's like line 4 or 5, scroll over to polar and hit enter. As soon as you do that, when you hit the y equals button, you'll see it's a little different. It's in terms of r. So we can graph in our graphing calculator anything in terms of r. So we're going to graph secant theta, tangent theta. There is no secant button in your calculator, but you know that secant's 1 over cosine. So use parentheses and type in 1 over cosine. Now, our theta is our variable button. You know, the button that we've used x for is now our theta button. Theta is the third variable in. So you do 1 over cosine theta, end your parentheses, tangent theta. And when you hit graph, you should get a really nice parabola. Well, y equals x squared is a parabola in rectangular, and r equals secant theta, tangent theta is r in polar. Okay, let's go back and do A, the one that they said to do last. I think that we should go ahead and multiply this out. So let's do that. It's x squared minus 6x plus 9 plus y squared equals 9. Okay, well, the 9's cancel. So we have x squared minus 6x plus y squared equals 0. Okay, I want this in terms of r. The nice thing, we've got, look at up here, we have x squared plus y squared equals r squared. So I'm going to swap those out, and I'm going to say r squared minus 6x equals 0. And then I'm going to do r squared equals 6x because I'm going to use the x. Is r cosine theta. So I'm going to say that that's 6r cosine theta. Swap out for the x. I'm going to divide by r. So r equals 6 cosine theta. And I'm done. Now let's go back. This is an equation of a circle that goes to the right. The center is 3, 0, and the radius is 3. Well, if you type r equals 6 cosine theta into your calculator, and it's most likely going to look a little bit like an oval, but that's okay because your calculator, the dimensions are rectangular, meaning that they're not square. You will get a circle that goes to the right 3 and has a radius of 3. Okay, so we've done 3 rectangular to polar. Now we're going to go polar to rectangular. So here we go. R equals -3. Well, r equals -3. A radius of -3 is going to give you a circle. What it's saying is the extension is -3, and then whatever theta that you get, wherever that lands up, you're going to get a circle. Okay, I know that x squared plus y squared equals r squared. So why don't we plug -3 into that? So we get x squared plus y squared equals 9. Lovely. And then we're going to solve for y. To make it rectangular, we'd always write in terms of y. And then we'll take the square root, plus or minus the square root of -x squared plus 9. 2 separate equations. The first one is going to give you the top part of your circle, and the negative part would give you the bottom of your circle. Okay? This next one I'm given a theta equals 4 pi over 3, and why don't we use tangent? Tangent theta equals y over x, because we're trying to write this in rectangular, so we're going to maybe swap out theta equals 4 pi over 3 and use the fact that inverse tan of y over x equals theta. So inverse tan of y over x equals 4 pi over 3. Okay, so I want to get y over x by itself, so I'm going to take the tangent of both sides to undo the inverse, and I'm going to say y over x equals the tangent of 4 pi over 3. We know the tangent of 4 pi over 3. Tangent of 4 pi over 3, it's positive in quadrant 3, is root 3 over 2 over 1/2, which just gives you root 3. So we have an equation, y equals root 3 times x in rectangular. Okay, last one. This last one's a little gross. I'm going to absolve us from actually finishing this problem. I want to swap out x. I want it to be x and y. So what if we multiply this whole thing by r? So we have r squared equals r minus r cosine, I keep doing that, cosine theta. Then I can actually do some swapping. So r squared is x squared plus y squared. R is equal to the square root of x squared plus y squared, right? Minus r cosine theta is x. Okay, and herein lies why I say we don't have to finish it. We'll write solve for y, smiley face, because ew. To solve for y, you'd have to do a lot. And we're not willing to do that, and YouTube can't hold this video if I go any further. So your homework problems and test questions won't be quite that tough. So here's our homework. There's some mixed review in here, and then the new stuff. So this is review, changing from polar to rectangular. And it looks like these are too. So more changing polar to rectangular. You can do the suggested questions with the circles or if you're feeling fairly confident in that, you can skip it. This is the work that I need you to know how to do. And then FYI, if you made it to the end of this video, I hope you did, you do not have to write all of these in terms of y equals. Y equals is a nice little trick if you're trying to write something into your calculator, but it can be kind of a bear sometimes. I feel like all of these were fine because we're changing rectangular to polar. That's not usually the issue. There are some goofy ones in here. So once you get to this slide, as soon as you have it in terms of just x and y, you can leave the problem alone. You don't have to write it in terms of y every time. So like number 77, you can get done in 1 or 2 steps. And you'll see what I mean once you get to the last slide, like the super challenge. It looks kind of familiar, right? It looks like that problem, the last problem that we did in the notes. So, oh, it's not even circled. So, like I said, feel free to leave it in terms of x and y. You don't have to write the equation in terms of y. Lovely. Have a good Tuesday. Bye, guys.